Why can birds land on power lines and not get electrocuted, but you see in the movies people grab power lines and they get shocked? Well, the answer has to do with the fact that they only land on one power line. But to really understand why they're not getting electrocuted, you have to understand a little bit about how electricity works. So electricity is simply electrons moving through a wire. But what causes them to move? What's making them move? There's a difference in electric potential that causes them to move. They want to move from high electric potential to low electric potential. To understand that better, let's think of an analogy. Think about taking a bowling ball and climbing up a hill and dropping that bowling ball. That bowling ball is going to roll down that hill. But why? The simple answer is gravity, of course. But you can think of it in another way. As the bowling ball increases in height, its gravitational potential energy increases. Now, all things in the universe that occur naturally occur to minimize their potential energy. So the bowling ball wants to minimize its potential energy. So it wants to go from a position of high potential energy to a position of low potential energy. And electrons in a wire want the exact same thing. That's why electricity flows. Now, those of you who've been paying attention will notice that initially I said electric potential. They want to move from high electric potential to low electric potential. And then I talked about gravitational potential energy. So it wants to go from a position of high potential energy to a position of low potential energy. So why didn't I say electric potential energy? Well, I kind of am talking about electric potential energy. Electrons in a wire want to minimize their electric potential energy. But electrons are so small. Electrons are tiny. So each electron itself only has a tiny, tiny bit of electric potential energy. So to make things easier to talk about, to make them more quantifiable, instead of talking about the amount of electric potential each electron has, we talk about them in a group of electrons that we call a coulomb, and we talk about how much electric potential energy that coulomb has in this part of the circuit versus in this part of the circuit versus in this part of the circuit. And the amount of energy per coulomb is the electric potential. So we still are talking about electric potential energy, but we're using the context of electric potential, the amount of energy per coulomb, to talk about it more simply, because again, each electron has such a tiny amount of energy. So why does electricity flow? Why do electrons move in a circuit? Is to go from a position of high electric potential to a position of low electric potential. Now let's go back to the bird. The bird lands on one wire of these power lines. And that's important because each wire is at a different electric potential. And so when the bird lands on one wire, its 2 feet are essentially at the same electric potential, which means that there's no incentive for the electrons to go from one leg of the bird through the bird and out to the other leg of the bird, because the electric potential is the same. The other reason is that the bird's electrical resistance is so much higher than the wire's electrical resistance. Electricity flows through the path of least resistance. The copper wire is a much better conductor, therefore much lower resistance than the bird's body. And so the electrons will flow through the copper wire instead of the bird's body because it's such a lower resistance. The bird doesn't feel anything, it doesn't get electrocuted. Now I mentioned that it's really important that the bird only lands on one wire. This is true because the different wires on a power line are at different electric potentials. So if the bird standing on one wire were to take off and its wing touched another wire, then it would get electrocuted because the 2 wires are at different electric potentials. And let's say the wire that it's standing on is at a higher electric potential than the wire that its wing touches, the electrons will want to go from the higher electric potential wire through the bird's feet, up through its body, out through its wing, to that lower potential energy wire, therefore electrocuting the bird. Similarly, the pole that's supporting all these wires is connected to the ground, which is at a much lower electric potential. And so if the bird were to accidentally touch the wire, and then with its wing or with its other foot touch the pole that's connected to the ground, the same thing will happen. Electrons will flow from the high electric potential wire through the body into the pole down to the low electric potential ground. This is actually what happens a lot of the time with bigger birds, like vultures and eagles and hawks. They'll land and perch on the pole and then go to take off, and because their feet are touching the pole, their wing touches one of the wires, which is at a much higher electric potential, and they get electrocuted and they die. This is also why you see in the movies humans get electrocuted, because humans are standing on the ground most of the time, and if you touch one of these wires while standing on the ground, well, the ground is at a much lower electric potential than the wire is, and so if you touch the wire, the electrons will flow from the high potential wire through the person's body into the low potential ground, electrocuting the person. In fact, people that work on power lines sometimes will get airlifted by a helicopter in to repair electrical power lines. So they're hanging from a helicopter working on these power lines because then they're not connected to the ground. They're still just touching that one wire. All right, so hopefully now you understand why birds can land on electrical power lines and not get electrocuted. It's simply just because their 2 feet are at the same electric potential and their body is a much higher resistance than the wire that they're standing on, the copper wire that they're standing on. Okay, I hope I made that make sense to you. If I did, hit that like button, hit the subscribe button if you want to follow for more science content made easy. I'll see you in the next one. Stay curious, everybody. Bye.